All right. So when I teach you guys a concept, I look at the problem. And you guys know there are many ways to do problems. You could go this route, you could go this route. There's no one right or wrong way to solve a problem. There are definitely wrong, but there's multiple right ways. So what I do is I always choose the easiest method. And that's the method I teach you. The method that I feel like you're going to be the most successful at. I never teach two methods because I think teaching two methods is confusing. Show me how to do it. Don't show me two ways at the same time. That's going to freak me out. Just show me how to do it. So today I'm going to break my rule, and I'm actually going to show you two methods in the same day. And the reason I'm doing that, I know you guys are like, no. The reason that I'm doing that is because the first method is easy, but I don't think that's how the problem's going to be presented by Weber State. So then I have to take the easy way to do it and kind of change it to do it the way I think we're supposed to. Okay, so long story short, I'm going to teach you two methods today. Okay, and I'm sorry, that will not be normal. Okay, so if you look at these 5 graphs, those are called parent graphs. They're the generic graph, and then what you start doing is you start changing it according to the equation, okay? So let's just very quickly graph all of these parent graphs, okay? So y equals x to the second is a parabola, okay? So your pencil is at the origin, right there, your vertex. And then from there, you go right one up one, left one up one, right 2 up 4, left 2 up 4, and you graph in that parabola like that, okay? Now, in this box right here, I want you to write a equals 1. I'll explain that in a second. And then I want you to do these little steps like this, okay? On the steps, just so you guys understand, you don't have to put the dot right there. I'm just going to put it. I want you to know that that dot is the vertex. So the stretch of this parabola from the vertex is right one up one, so that's 1, 1. Then you put your pencil back at the vertex and you go right 2 up 4, so there's your stretch right there. Okay. Underneath that, I want you to write y equals ax to the second. A is some number in front of the x to the second. So if a is a 1, like on that example, f of x equals x squared, your a is a 1, then that's your stretch. But if a is not equal to 1, then here's what you do. You do the same stretch, you guys. You do 1, 1, 2, 4. This is called a vertical stretch. A vertical line, you guys, goes like this. So you take the vertical movement, which on these are the up movements, and you multiply it by a, whatever the stretch or the shrink is. So if you just take that 1 times a is a. If you take the 4 times a is 4a, okay? If that's confusing to you, don't worry. We're going to do more, okay? Okay, square root of x. Here's what the graph looks like. Pencil at the origin, and then the stretch is right 1 up 1, and then the next stretch is right 4 up 2, and your graph looks like that. Okay, so if a is 1, then your stretch is 1, 1, and then the next one was 4, 2. Underneath that, write y equals a times the square root of x. What if a is not equal to 1? What if it's like 2 times the square root of x? Or negative 1/2 times the square root of x? What do? Okay, well, you do the same stretch, 1, 1, 4, 2, but you do the same thing we did last time, which is take those vertical movements and multiply it by a. So 1 times a is a, 2 times a is 2a. Okay, let's do the next one. These are all just the parent graphs. So a cubic looks like this, you guys. Pencil at the origin, and then you go right 1 up 1. Someone tell me the next stretch. Does anybody know? 2 and then 8. Bless you. How do you know it's 8? How do you get that? 2 cubed is 8, right? 2 to the third power is an 8. But you have to balance on the left on this guy. So it's left 1 down 1, then right 2 down 8. That's what your graph is going to look like. Okay, so let's write our stretch. Okay, off to the side of that equation, say if A is a 1, so if the number in front is a 1, then your stretch is 1, 1, and 2, 8. You guys, if you forget the stretch, let me show you how to figure it out. Look, right and left movement is along the x-axis, so that's an x value. So if x is 1, 1 to the third is 1. If x is a 2, 2 to the third is an 8. The next one, let's see if you guys know, the next one would be 3, and then what would it be? 27, because 3 to the third is 27. Yeah. Okay, now underneath that, let's write y equals a, x to the third. And let's say that a is not 1. So you do the same stretch, which is 1, 1, and 2, 8, and you take those vertical numbers and multiply them by the stretch, which is a. So 1 times a is a, 8 times a is 8a. Okay? Square root, or cube root. Okay? Pencil at the origin, and then you go right one, up one. You balance that with left one, down one, and then you go right 8, which is to the end of that graph, up 2, and then go left 8, down 2. So this is what it looks like. It's like a cubic on its side. It's cube root. Okay, let's write our stretch down. If a is equal to 1, then your stretch is 1, 1. Guys, look, the right is the x, so the cube root of 1 is 1. The next one is 8, because the cube root of 8 is 2. So you can just figure it out if you need to. Everybody write y equals a times the cube root of x. What if a is not equal to 1? You do the same thing we've done on all of them. So you duplicate that stretch, 1, 1, 8, 2, but you take your vertical numbers and times them by a. So 1 times a is a, 2 times a is 2a. That's it. Who says I'm totally with you? I'm following just fine. Give me some feedback. Okay, good. Okay, next one. Absolute value. So an absolute value looks like this. Pencil at the origin, and then you go right one, up one, right one, up one, right one, up one, right one, up one, left one, up one, left one, up one, left one, up one, left one, up one. Draw in the graph, and it looks like that. So this is the only graph where I don't go back down to the vertex. I just do this, guys. I go 1, 1, and then I just keep repeating that. Excuse me. That's if a is a 1. Okay, so underneath that, let's write y equals a times the absolute value of x. What if a is not equal to 1? Then you go right 1, up a, because 1 times a is a, and then you repeat it. So you don't go back down to the vertex on that one. Okay? All right, so let's come over here. I'm going to kind of jump all around today, so just be prepared for that. Okay, look right here. See this D? Draw an arrow to that. Okay? You guys, the D is outside of the f of x. Okay, I want you to write down that word outside. If it's on the outside, like see this 1, that's on the outside. Everybody look right here for 2 seconds. This is on the inside. So this guy right here is within the x squared. That's called inside. This 1 is out on the outside. Who says I understand the difference? Let me see. Okay, great. So if it's on the outside like that, then it's going to move your graph up or down. Okay? If it's a positive, you go up. If it's a negative, you go down. Now, for about, I don't know, 4 years or something really long, I've had to make my students do this. Graph the parent, write the word parent, write the equation for the parent, and then on the next one, write the description up 1, write the equation, and do the graph. It was just this thing that Weber State made us do. I don't think they're going to make us do it anymore. So I'm not doing it anymore. So this graph right here, you don't need to do it. You can just go right to the actual graph. Okay, so see that +1 right there? Underneath, I want everybody to write up 1. Okay, so now you take that parent graph that we just graphed and you shift it up 1. So now my vertex is right there. The stretch is the same. Right one up 1, left one up 1, right 2 up 4, left 2 up 4, draw your graph in. That's literally all you have to do. Done. Okay, look at this next one right here. See the second graph? You guys are so lucky. If I told my last semester students or any of my of the past 8 semesters that you don't have to do multiple graphs, they would be like, oh my gosh, they're so lucky. They don't have to do all the graphs that you used to make us do. Okay, everybody in the room, tell me what that minus 3 does to the graph. Down 3. I literally want you to write the words down 3. Okay, pencil at the origin, go down 3. Now you have to remember what an absolute value graph looks like and what the stretch is. The stretch is normal. So it's going to be right one up one, right one up one, right one up one, left one up one, left one up one, left one up one. Draw your graph in. It's a V and you're done. Very quick. Okay? All right. Look at this guy. If it's within the equation, okay, look right here, guys. See this x minus 2 right here? Do you see how it's inside of the square? Okay, I want you to write the word inside. And that inside kind of has to do with the second method I'm going to show you in a minute. Okay, so if that number is inside, then it shifts your graph where or where? Tell me. Yep, right or left. Good. Okay, so everybody write right or left. I also want you to write this phrase down, and I want you to remember it. The x lies. The x is a liar. So whatever's happening to the x, you actually have to do the opposite of what you think it is. Okay, so you would think if it's a positive sign that you go right, but x is a liar, so it's actually the opposite. So if the middle sign is a positive, pardon me, you go to the left. If the middle sign is a negative, you go to the right. Okay, so this one right here, it's with the x, but the x lies. So negative 2, you would think left, it's actually right. So you're just going to take that graph and shift it to the right 2. Pencil at the origin, go right 2. There's your vertex. It's an x squared. You have to know what that looks like. It's a parabola. Normal stretch. Right one up one, left one up one. Right 2 up 4, left 2 up 4. Draw in your parabola, and there is your answer. Okay? Who says I'm totally with you? This is a piece of cake. Let's see how we're doing. Okay, great. This one right here. It's on the inside. The x lies. Okay? So we're going to go, everybody in the room, tell me what it is. It's left 1. Okay, pencil at the origin, go left 1. Now that's great, but if you don't remember the stretch for a square root, then you're going to miss it. Pencil at the origin, everybody tell me the first stretch without looking at your notes. What do you do? 1, 1. Back to the point, and then what do I do? 4, 4, 2. Square root of 4 is a 2, right? Draw it in. There's your graph. That's all I'm going to make you do. Okay? Okay, this one right here. Get rid of these graphs right here. You don't have to do 3 graphs now. I want you to list the transformations. Everybody in the room, tell me what the minus 3 does. Down 3. Talk to me about that minus 1. What does it do? It's the opposite of what you think, right? So negative you would think left. It's actually right. So it's going to be right 1. You guys, this is an x squared, so I know it's going to be a parabola. So take your pencil, put it at the origin, go down 3, and right 1. Now it has a normal stretch. Right 1 up 1, left 1 up 1, right 2 up 4, left 2 up 4, draw in that parabola. Looks about like that. Okay, now they're asking you more questions about that problem. Okay, find the domain. You guys, you can find the domain from the equation, or you can find the domain from the graph. I think you're going to be way better at finding it from the graph. Okay, so look at that graph. Domain is x. Start to the left, travel to the right. Every person in the room, tell me what the domain is. All real numbers. So write it as all real numbers. Write it as negative infinity to infinity, but don't write it both ways. I have some people writing it all real numbers, comma, negative infinity to infinity. No, choose your method and then stick with just that method. Okay, range is y, start low, move to the top. The first place it hits is a negative 3. Does it actually hit a negative 3, everybody? Yes, it does. So I close it with a bracket, and then it goes to, talk to me, infinity, okay? X-intercept and y-intercept, you guys, you have to write those as ordered pairs. So the x-intercept is found by letting y be a 0, the y-intercept is found by letting x be a 0. You guys, look at your graph. The y-intercept, you can see is 0, -2. So I'm just going to fill that in and I'm done. The x-intercept is not clean. It's not a perfect point. You can't guess. You can't just say, oh, it's about 2.8, so I'll put that in. No, you can't do that. So look what we're going to do. We're going to go into the equation, and where I see a y, which is the h of x, I'm going to put in a 0, okay? So everybody write down 0 equals x minus 1 to the second minus 3. All I did is let your h of x or your y be a 0. Okay, now you tell me, I'm trying to solve this for x, you guys, so what do? Tell me what to do. Tell me loud, you don't have to be afraid in here. What do? Move your 3, yeah? So I have the absolute value of x minus 1 squared is equal to 3. Listen for a second, will ya? I could multiply x minus 1 by x minus 1, FOIL that out, pull the 3 over, and then try to factor it. Would that, and then it probably won't factor, so I'd have to use quadratic formula. That's a lot of work. It's way, way easier to just do what, everybody? Square root it, right? So let's square root the right and the left. And then you get x minus 1 equals. Some of you are forgetting this. I know you're forgetting it because I'm grading quizzes and you're missing it. What comes right after the equal sign? Plus or minus. When you take the square root, you have to put a plus or minus in front of it. Good. Move the 1 over. It comes over and becomes a positive, so you have 1 plus or minus the square root of 3. Now, those are x-intercepts, so come back over here. Those have to be written as ordered pairs. I would not do the plus or minus on an intercept. I would write those as 2 separate intercepts. So I'm going to write that as 1 plus the square root of 3, 0, and then 1 minus the square root of 3, 0, and that's it. Okay? Now I want you to write a note right there to yourself. Okay, write this down. Never, and underline the word never. Okay? Never write an answer in decimal form unless, anybody in my 1010 class, you better know the answer to this question because I pounded it in your head. Finish my sentence. Unless they tell you to. Yes, unless they tell you to. They might say, round it to the 3 digits or whatever. Did they tell us that? No. So we can't put that in decimal form. We have to leave it in exact form, which is exactly what we just did. Okay? Okay, 2 more little things, and then I'm going to start talking about the second method, okay, which I have to do, and I'm sorry. Okay, if you alphabetize x and y, the x comes first, okay? So I want everybody to write x first, y second. This is how I remember which one's which. The x comes first. If the negative comes first, meaning like that, it's at the front of the function, that is an x-axis reflection, okay? So that is a reflection across the x-axis. If the negative does not come first, if it looks like that, that's a reflection across the y-axis. So it's easy to see if the x is out in front or if the negative's out in front, that's x. If it's inside, it's a y, okay? So look at question 4, okay? Cross out that second graph. The negative is on the outside, so we're going to say reflect across the x-axis. Now, everybody look right here. Here's a square root graph. It looks like that. So folding it across the x-axis is just going to make that guy come down. So it's going to be right here. Then it's going to be right 1, down 1. Pencil back at the origin. Right 4, down 2. Graph it in. And there you go. That easy. Okay? Who says, I am fine with this lesson? I want feedback. Okay? If you're not fine, don't raise your hand. But if you are, raise your hand. Let's see how we're doing. Okay, good. Okay, this one. If it has a negative, I know I have a reflection. Okay? This has a reflection, or has a negative, so I'm going to say reflect. It's not the x though, because the negative's not out in front. So this is to reflect across the y-axis. This is a square root graph, looks like that. So when I fold it, the right's just going to come over to the left. So it's going to be right here, left 1, up 1, left 4, up 2, graph it in, there's your answer. That's it. Okay? All right, now we're going to do stretches. Do you see that x to the second? If the number, write this down. Okay, see this right here? Y equals a times f of x. Draw an arrow to that a, and I want you to write down that it's either a stretch or it's a shrink. If the absolute value of a is greater than 1, it's a shrink. It's a stretch, pardon me. If the absolute value of a is less than 1, it's a shrink. Don't let the absolute value freak you out. It's just saying don't look at this sign. So see this 3 right here? The absolute value of 3 is a 3. 3 is bigger than 1. This is a stretch. Okay? So come right here, get rid of that. And for the description of what's happening, I want you to say this is a vertical stretch by a factor of 3. There's no right, left, up, down movement, so it's still here. I know this is a parabola because it's squared. Let's write down the normal stretch. You guys look. For a parabola, 1, 1, 2, 4. Okay, now everybody look right here for just a second. I'm going to show you something. Here's a parabola. Okay, look right here. If I'm stretching it vertically, this is vertical. So if I'm stretching it vertically, do I do this with my fingers? Do I pull them up? Or do I do this? Pull them down. Which one? Stretching it vertically. Tell me. Up. This is a stretch. So it's going to be tall and thin. Okay? So you take those up movements, 1 and 4, and you times them by this number right there, which is a 3. So 1 times 3 is 3, and 4 times 3 is 12. Now put your pencil at that vertex, go right 1 up 3, left 1 up 3. You guys, the next one is 212. That 12 is too big. It's off my grid. Okay? Look right here for a second. Please don't do this. I need somebody to tell me what's wrong with that. It looks like an absolute value. Looks like a V. You're exactly right. Why does it look like a V?
It's going past 2.
It's not, you're exactly right. It's not supposed to hit an x value of 2 until you're all the way up at what? All the way up at 12. So you've got to be careful, okay? You've got to be very careful when you do this. So look, guys, you have to make it really, really, really narrow. And like Spencer was just saying, don't touch that value of 2. Just make it very, very steep like that, okay? Okay, good. Look at this one. Get rid of the second graph. 1/2. This is called a vertical. A vertical, what is that called, everybody? Is it a stretch or is it a shrink? It's a shrink. So we're going to say vertical shrink by a factor of 1/2. It's a shrink because 1/2 is less than 1. If we look right here, here's my x squared. The shrink goes like this. You shrink down. Like if you're shrinking, you're going down, right? So here's normal, and I shrink it vertically. Looks like that, okay? So I don't have a right, left, up, down. I don't have anything like that. Normal stretch on a square root is 1, 1. What's the next movement on a square root? 4, 2. Now I take those up movements and I times them by 1/2. So 1 times 1/2 is 1/2, and then 2 times 1/2 is 1. So there's my stretch. Pencil at the origin, right 1 up 1/2, left 1 up 1/2, right 4 up 1, right 4 up 1. You still have to make it very V-shaped. This is kind of crazy. I feel like I did something wrong.
It's a square root.
Oh, I'm doing a parabola. It's a square root. Thank you for correcting me. I'm like, what am I doing wrong? Good. Set it on my seat, okay, buddy? Thank you. And then graph it over, and it looks like that. Thank you for the correction. I was like, why does my parabola look so weird? It's a square root. Okay. We are going to do one more. And then, I wonder if I really want to do one more. No, I don't. I'm going to zip down here. Okay. Look at questions 7 and 8. If you're not paying attention, that's your choice. I really think you better pay attention to this. Okay. This concept, example 8, was just on my student's final. I think it will probably be on your final. It could also possibly be on your midterm. Okay, so everybody look at this. The thing that makes this difficult, that graph that you see, that's not a parent graph. You don't have the stretch memorized. You don't even have an equation. Okay, so it makes it kind of difficult. Somewhere around that box right there on page 19, I want you to write this down. Okay, I want you to write inside. If it's on the inside, it affects the x. Then maybe draw a line like that. If it's on the outside, it affects the y. Over on x, I want you to say the x lies. Okay? So, I'm going to show you a little example. I want you to try to squeeze this in somewhere, okay? F of x equals negative x plus 2 squared minus 3. Just some equation. And then look what I want you to do. I want you to go x becomes and y becomes. Okay, now watch this closely. Anything on the inside affects the x. So see this plus 2? That's going to change the x value, but the x lies. So it looks like adding 2, you do the opposite, which is subtract 2. So x becomes x minus 2. Anything on the outside, which is all this yellow stuff right there, it affects the y, but the y tells the truth. So the y has to be multiplied by a negative 1, and then you have to subtract 3. So I'm going to say y becomes a negative y minus 3. Okay, so write that down. Basically, when you're finding your y adjustment, this parent business right here, you can just write it as a y. So negative y minus 3. Okay, let's do one more, and then we're going to go back up to the top. Okay, so f of x equals 2 times x minus 1 cubed plus 1. Okay, this is method 2, by the way, in case you haven't figured that out yet. Okay, so anything on the inside affects the x, but the x lies. So x becomes x, talk to me everybody, plus 1 is correct. What happens to the y? See this part right here? Turn that into a y, because the 2 and the 1 are outside of the function. So y becomes 2y plus 1. That's what I need you to understand so far. Who says I'm with you? Raise your hand up high. Okay, great. I want you to go back to the very tippy top of these notes. Okay, go back to right here. You guys, I do not think you're going to have a question like this. Sorry, didn't mean to cross. I meant to highlight. I don't think you're going to have a question like this on your midterm. I don't think you're going to. I think when it's on your midterm or on your final, it's going to look like at example 8. Okay? If this does come up on your midterm, I would never use this new method. I would go up 1, it's a parabola, it takes me 15 seconds. Same thing right here. It's an absolute value, it's shifted down 3, sketch it in. Literally, you could do that thing in 30 seconds. That one's a right 2. So I'm going to show you how to use method 2 on these, but I would never do it. because it's so easy just to shift it up, okay? Okay, come back up here to the top. See that x to the second? I want you to write down some ordered pairs on the parent graph. Let's write down 0, 0. Underneath that, write 1, 1. Underneath that, write 2, 4. And then I want you to draw an arrow like that. Because then what you're going to do is you're going to change those values depending on the transformations on the equation. Okay? Look at a square root graph. Let's plot down a couple of points. 0, 0, 1, 1, 4, 2. And then I want you to draw arrows because that's how you're going to set up the new method. Okay? Next problem, on a cubed, a couple of points I want you to choose would be 0, 0, 1, 1, 2, 8. And then you would draw your arrows and you would change those points. Okay? The cubed root, I would choose 0, 0, 1, 1, and 8, 2. And then I would draw my arrows and I would come up with adjusted points. Okay? The last one is absolute value. Choosing 3 points, I would choose 0, 0, 1, 1, and 2, 2. And then I would draw the arrow. Okay? Let's go ahead with question 1. I know you've already done it. I would never use the method that I'm about to use on question 1. Question 1 is so easy to graph if you just shift it up 1. I'm trying to show you how to use method 2 with an easy example. Okay? X to the second is a parabola. 3 points on a parabola would be 0, 0, 1, 1, 2, 4. I'm going to change those points. I need to change the x value and potentially change the y value. Any changes to the x, you guys, are going to be right here. Look. Inside of the x. Is there anything inside of the x squared? No, there's no changes. So x is just going to stay in x. The 1 is on the outside of that x squared. It affects the y, and the y tells the truth. So y becomes y plus 1. Now what I'm going to do, guys, is I'm going to apply that to those 3 points. So look what you do. The x's don't change. That's because there was nothing in parentheses with the x. The y's, you add 1. 0 plus 1 is 1. 1 plus 1 is a 2. 4 plus 1 is a 5. Now look at the correct graph. 0, 1 is a point on the graph. 1, 2 is a point on the graph. 2, 5 is a point on the graph. You can graph it from those points. Okay? Okay, let's do the next one. Question B. New method, which I would never use the new method on this problem. I'm just explaining. Okay, so everybody go, x becomes, sorry, 2 seconds. My pen is not wanting to work. Oh, yay, there it goes. Okay, so everybody go, x becomes, and y becomes. Any changes to the x are in parentheses right there. There's nothing there. So x stays x. Anything on the outside affects the y. So y would become y minus 3. Who says I'm totally following you? Raise your hand up high. Okay, ordered pair on an absolute value would be 0, 0, 1, 1, 2, 2. Now I'm going to change them. So the x's stay the same, 0, 1, and 2. To all of those y's, you subtract 3. So 0 minus 3 is a negative 3. 1 minus 3 is a negative 2. 2 minus 3 is a negative 1. Look at the correct graph. It contains all those points. Don't go right or left, but go down 3, write 1 down 2, write 2 down 1. Same thing on the other side. I got it. Okay? Okay, I'm going to skip all the way. You get the idea. I don't need to go through the method with all this stuff. I'm going to skip all the way down to question number, right here, question 6. Okay? I've given you 4 graphs. You don't have to do 4 graphs. You only have to do 2 graphs, or 1 graph. Okay? Now, let's figure out what x, how to change x and how to change y. So everybody say x becomes and y becomes. Okay? Anything inside the function, which I've just highlighted in green, affects the x, but the x lies. So x becomes x, can anybody tell me? It is +1. It's the opposite of what you see. Okay? Then, what's on the outside of that, what's not highlighted in green, is the -2. So you take the y and multiply it by a -2. That's it. Okay? Let's write down some points for an absolute value. When I do this, you guys, I visualize the absolute value and I just write the points down. So those points would be 0, 0, 1, 1, 2, 2. Now let's change them. Take the x value and add 1. 0 plus 1 is a 1. 1 plus 1 is a 2. 2 plus 1 is a 3. Take the y value and multiply it by -2. 0 times -2 is a 0. 1 times -2 is a -2. 2 times -2 is a -4. I want you to keep in mind that this is a v. Okay? Let's plot those points. By the way, put a v right here, you guys. Put a v by the ordered pair 1, 0 and put a v by the ordered pair 0, 0. That's telling you that that's the vertex of that absolute value. Okay, so everybody plot the point 1, 0. I know that's going to be my vertex. 2, -2 is right here. 3, -4 is right there. Well, if that's the vertex, then I know this guy's going to have to go that way. Then I have to duplicate those points on the other side, and there it is. And that makes sense to me because, look, I was supposed to shift my graph right 1, opens down, and it has a stretch of 2. Right 1 down 2, right 1 down 2, repeat. Okay? Who says I followed that entire thing? Let's see. Okay, yay. If you followed that, we're on our way. Okay, let's do question 7. True or false? F of x minus 1 is this graph of f of x shifted to the left 1. You guys, this is on the inside. It affects the x. The x lies. So that -1 shifts it where? To the right 1. Everybody write down the word right, the words right 1. Okay? So they're saying left 1, that is false. Okay? All right, here we go with question 8. After question 8, we're done. I do need to talk to you about one thing. I want you to listen, okay, for a second. What I'm about to say, freaked my 7th period out. And I had probably 5 people that were really struggling with this concept, this example 8, which this is how it's going to look like on your Weber State stuff. And I feel like if I could get past that hump, then this is going to go way better. So everybody watch. Just watch. If you had y equals negative f of x, okay, that would mean to take that graph and reflect it across the x-axis. X because the negative is coming at the front. Okay? There's something called end behavior. We did not talk about it in Math 1010. Have you ever heard the words end behavior before? Have you done that? Okay, great. If you look at that parent graph, on the left side, your graph is pointing down. On the right side of the graph is pointing up. This is the end behavior of the parent graph. Who says, I gotcha? Let me see up high. Great. Now listen. If I took this graph and reflected it across the x-axis, look what would happen. Do you see how this comes up forever? When I reflected it, it would be going down forever. Do you see over here how it's down forever? When I reflected it, it would be up forever. So if there's a reflection, my end behavior changes. So a reflection across the x-axis makes your end behavior go, it's the pink marks, left up and right down. So an x-axis reflection changes your end behavior. Who says I understand that? Give me feedback. Let me see how we're doing. Okay, let's talk about a y-axis reflection. Okay, so everybody over here write y equals f of negative x. Now the negative is within. That is a y-axis reflection. Okay, everybody watch this. Here's this yellow. If I fold it across the pink and reflect it, the yellow goes up there. If I fold it across the red, sorry. On the left-hand side, this goes down. If I fold it across the red, it goes over here, down. So my end behavior would then be my pink lines, which would be left up and right down. Who says I understand? Raise your hand. Let me see. That's what people couldn't get past. An x-axis reflection or a y-axis reflection changes the end behavior of the graph. Okay? All right, let's do this. Let's do question A. Okay, let me just kind of tell you. This semester it's going to go so much more smoothly than last semester. I didn't really know that I had to teach this concept in that manner to my last semester students until like a week before the final. So I was trying to cram this in their brain right before they took the final, plus review everything they've learned. It was bad. But now I know I have to, so I'm teaching it when I should. And then we're going to practice, and it's going to be on quizzes and tests, and you're going to be great at it. It's going to be way better than a week before the test. Okay, let's do the x becomes and the y becomes. Okay, inside of the f of x, there is nothing there. There's not like a +1 or multiplied by 3 or anything like that. So x is just going to stay an x. Anything on the outside affects the y. See that f of x, you guys, that I just highlighted in yellow? Just write it as a y. So that would be negative y plus 2. You have to multiply it by negative and then add 2. Now, go to that graph, that parent graph, and let's write down some points. I'm going to do that one, and that one. Okay? So the ordered pair on the left is negative 1, 0. The next one is 0, 4. And in front of that 0, 4, I'm going to put a T. And the reason is that's a turning point. When I hit that 0, 4, it turns the other direction. The other point is 2, 0, and that is also a turning point. Okay? So now I'm going to write those 3 points down. Negative 1, 0, 0, 4, and 2, 0. And I'm going to keep those T's in front of the 0, 4, and the 2, 0. And then I'm going to change these points. Okay, so everybody go like this, change these points. So the x's don't change. They stay negative 1, 0, 2. The y's, you have to multiply by a negative and then add 2. Do I multiply by negative and then add 2, or add 2 and then multiply by negative? Which one do I do? Multiply first, right? So 4 times negative 1 is negative 4. Negative 4 plus, oh, let's do the 0, sorry. 0 times negative 1 is a 0. And then add 2, you got a 2. 4 times negative 1 is negative 4 plus 2, negative 2. 0 times a negative is still a 0, plus 2 is a 2. Put a turning point, okay? Talk to me about my end behavior on this graph, you guys. Do I have any reflections in this equation? Talk to me. Yes, there is an x-axis reflection. So it's not going to be left down, right up. It's going to be like this. That's going to be my end behavior. It's going to change because I have a reflection. Now let's plot the points. Look, guys, left 1, up 2. Don't go right or left. Go down 2, and I'm going to put a T there because that's a turning point. 2, 2, right 2, up 2, that's a turning point. I know that the left part of my graph is supposed to be up. Look, guys, that's supposed to be up. So it's going to be like this. It's going to be up. I'm not turning when I hit that. Once I hit that, I do turn. Then I head over here and I hit that guy and I turn. And then I'm going to turn and I'm going to come down. And it looks like that. And I'm done. Okay, that's what it was like on the final. Let's do the next one. Nice and slowly. Okay, here we go. Let's do x becomes, y becomes. The x is in here, whatever affects the x. But the x lies. So this guy's multiplied by negative 1. So my guy's going to be what? What's the opposite of multiply? Divide. So it's going to be x divided by negative 1. You have to do the opposite. The only thing that affects the y is the negative 1. So y becomes y minus 1. Write down those 3 points that we started with, you guys. They were -1, 0, 0, 4 with a t in front of it, and 2, 0 with a t in front of it. Okay, and now I want you to change them. So the x's, all you do is just change the sign. Dividing by -1 just means change the sign. So now I have 1, 0, -2. Take the y and subtract 1. 0 minus 1, -1. 4 minus 1, 3. Put a t in front of that point. 0 minus 1, -1. Put a t in front of that point. Do I have, before I start graphing, I'm going to figure out my end behavior. Do I have any kind of reflection on this graph? Talk to me. Yes or no, guys? Yes. I have a y-axis reflection. Remember, that's going to change your end behavior, so it's left up, right down. Let's plot those points. 1, -1, right 1, down 1. 0, 3. Don't go right or left, but go up 3, and I'm going to put a t right there. -2, -1, left 2, down 1, and I'm going to put a t. Now I'm going to start graphing it. I know the left part is supposed to be up. So look, guys, I come like this. I'm up high. I hit that graph. I turn. I come over here. I hit that graph. I turn. And then I come down. And I don't turn there. I just stay down. I ended the right down, and I was supposed to end the right down. I'm done. There's my graph. Who says I totally get this? Raise your hand. Let me see how you're feeling. Okay. Yay. This was just on the final. I'm sure I would bet $10 right now that it's going to be on your final. And I don't like to bet, so I'm pretty sure. Okay, let's do this. X becomes, the change to the X is here. Everybody in the room tell me, X becomes what? Talk to me. X minus 3. Yeah. The Y becomes, tell me what to write right here. 2y minus 1. Very good. Okay. Let's write down those points we wrote down. Those were -1, 0, 0, 4 with a t in front of it, and 2, 0 with a t in front of it. Now let's change those points. Take the x and subtract 3. -1 minus 3, -4. 0 minus 3, -3. 2 minus 3, -1. Turning point, turning point. Take the y, multiply it by 2, and subtract 1. So 0 times 2 is 0, subtract 1 is a -1. 4 times 2 is 8, subtract 1 is 7. 0 times 2 is a 0, subtract 1 is a -1. Do I have any reflections on this graph? Talk to me about that. Yes or no? Nope, no negatives. So my end behavior is going to be the same as the original, which is left down, right up. Okay, let's graph this, guys. So you go left 4, down 1. No turning point there. Left 3, up 7. That's right there. And I'm going to put a T because it's going to turn. -1, -1, left 1, down 1, and I've got a turning point. The left part of your graph is down. So it's like this, guys. Look, down, don't turn. Come up, hit that guy and turn. Come down, hit that guy and turn. Head up, graph looks like that. It was supposed to be up. I'm fine. Okay, they're asking us another question. G of -3. You guys, that -3 is an x value. So if I go to an x value of -3, what's the point? Right there. Someone tell me what G of -3 is. It is 7. It is not the ordered pair. It's just the y value. It's just the 7. Okay? Okay, one more and then we're done. I know this was long, but so much better than last semester. Okay, let's do the x becomes, y becomes. Anything within the f of x affects the x. This one's a little bit tricky. The 2 is multiplied by the x. So what do I do on mine? You divide. Yeah, divide by, not by x. What's multiplied by the x, the 2, so you divide by 2. Okay? Everything on the outside is the y, so y becomes 2y plus 1. Let's write down those points that we had on the original one. They are -1, 0, 0, 4, and 2, 0. I'm going to put t's in front of the second 2 because they are turning points. Now I'm going to change the points. So I'm going to take the x's and divide it by 2. I get a negative 1/2, then a 0, and then a 1. Take the y, multiply it by 2, and then add 1. 0 times 2 is a 0. 0 plus 1 is a 1. 4 times 2 is 8. 8 plus 1 is 9. This is 2, 0, I think, right? Yeah. 0 times 2 is a 0. 0 plus 1 is a 1. Put t's right here. Do I have any reflections? Talk to me about reflections. Yes or no, everybody? No reflections. So the end of the graph, the far right and the far left, are going to look the same as the original. Okay? Go left a half, up 1, right there. Don't go right or left, but go up 9. Right there, I think it is. And I'm going to put a T right there for a turning point. 1, 1. Put a point right there, turning point. The left part's supposed to be down, so it's going to be left down. Come up, hit it, turn. Come down, hit it, turn. Head up. There's my graph. Done. Okay? All right, there's your homework right there. Okay? That's what you need to do. Aren't you glad you took this lab, everybody?